A monopoly represents total market control. But on the exact opposite end of the spectrum is an environment where control is completely stripped away. We call this theoretical extreme perfect competition. Imagine a massive agricultural silo. When millions of bushels of wheat pour onto an industrial scale, it's impossible to trace a single grain back. This absolute anonymity requires 5 structural conditions: a massive number of competing firms, identical products, perfectly mobile factors of production that allow free entry and exit, complete information, and a condition known as being a price taker. Because the output of one firm is physically indistinguishable from another, brand loyalty simply doesn't exist. Buyers have perfect information about the market, meaning they will invariably purchase from whoever offers the lowest price. This dynamic forces the individual producer into the role of a price taker. They possess zero leverage to negotiate or raise their selling price above the market rate. If a firm cannot change the market price, then the revenue gained from selling one additional unit, the marginal revenue, is always mathematically equal to that market price. If you cannot raise your prices to boost revenue, how do you survive? The answer depends entirely on your ability to calculate a highly specific volume of output. Survival here relies on strict cost optimization and determining your exact production quantity. Let's look at the quantity price graph for a single firm. Its cost structure is defined by 3 lines: a U-shaped average total cost curve, a lower average variable cost curve, and a swooping marginal cost curve. The constant market price is a horizontal line. To maximize profit in the short run, a firm must produce exactly where the market price equals its marginal cost. We locate that intersection and drop a vertical line to the x-axis. That provides our optimal quantity. We calculate the firm's exact profit with this equation. Profit equals the quantity produced multiplied by the difference between the market price and the average total cost. That difference defines the margins. If the price line sits above the average total cost curve, the firm generates a profit, represented by a green area. If the price drops below the curve, the firm operates at a loss, shown in red. But if a firm is operating in the red, logic dictates they should immediately halt operations. Why keep producing? In the short run, fixed costs, like a multi-year factory lease, are unavoidable. The firm must pay them whether machines run or are powered down. Operations only halt when the price drops so low that it cannot even cover the variable costs of producing the very next unit. The mathematical threshold for the shutdown is when price is less than average variable cost. Because production ceases the moment price drops below that threshold, the firm's true short-run supply curve is strictly the illuminated portion of the marginal cost curve, sitting above the average variable cost curve. Short-term market participation isn't always about making money. Often, it involves minimizing unavoidable losses by keeping enough cash flowing to cover your variable expenses. Now we scale up the analysis. We need to transition from the isolated individual firm to the aggregate macroeconomic market. Total market supply is derived through horizontal summation. We take the individual quantities produced by every single firm at a given price and add them up, morphing them together into a wider, flatter aggregate market supply curve. Expressed algebraically, if we have n identical firms, each with an individual supply function of little a plus little b times price, the total market supply is simply n multiplied by that function. By overlaying a downward-sloping demand curve onto this macro graph, the exact point where they intersect establishes the short-run equilibrium market price. Yet even at this macro scale, every single underlying firm quietly checks that final price, setting their production strictly where price equals marginal cost. Excess cash acts as a magnet. It incentivizes new competitors to flood into the space. New entrants mean more total product. This shifts the aggregate market supply curve outward to the right, which forces the equilibrium price downward. On the individual firm's graph, that dropping price line aggressively squeezes their profit margins. Conversely, negative profits cause firms to hemorrhage cash and exit. This decreases total supply, ultimately driving the remaining equilibrium price back up. This oscillation of entry and exit only stabilizes at zero economic profit. Firms earn enough to cover opportunity costs, but the surplus profit is zero. Mathematically, this long-run equilibrium locks in when the market price perfectly tangents the absolute lowest point on the long-run average cost curve. To find this exact minimum point on an exam, you take the derivative of the long-run average cost function and set it to 0. Perfect competition acts as a highly efficient processor. It auto-corrects excess profit, ensuring consumers always pay the absolute lowest sustainable price. While long-run economic profit is 0, firms still gain value from production. Economists quantify this using producer surplus. Looking at this pair of graphs, we can visualize the surplus in two ways. Focus specifically on the left-hand graph, highlighting the shaded rectangular block labeled producer surplus. This block illustrates our first formula. Producer surplus equals total quantity multiplied by the difference between market price and average variable cost. The right-hand graph demonstrates an alternative visualization, mapping the space bounded strictly by the marginal cost curve. This bowl-shaped area requires calculus. Here, producer surplus is the integral of price minus marginal cost, calculated up to the optimal quantity. Producer surplus is strictly distinct from profit. The only mathematical difference between the two figures is the firm's fixed costs. Because the surplus covers the area between cost and price, all possible gains from exchange are realized. This total efficiency is exactly why perfect competition is the theoretical baseline. Solving any exam question on perfect competition requires navigating three distinct mathematical thresholds. First, for any general profit maximization, always set price equal to marginal cost. Second, to determine if a firm survives the short run, test the shutdown condition. Is price strictly less than average variable cost? Third, to solve for long-run market equilibrium, establish the zero profit baseline by setting the derivative of long-run average cost to 0. Now it's time to execute. Head over to the learning area and apply these specific derivatives and integrals to the practice exams. Memorizing definitions won't secure the best grade. Mastering the underlying algebraic constraints will.